In amateur radio, a pan adapter, short for panoramic adapter, is a device or software feature that provides a real-time visual display of radio signals across a wide band of frequencies. Instead of just listening to one specific frequency at a time, a pan adapter lets you see the radio spectrum. It turns your radio experience from purely auditory to highly visual. Here is a breakdown of how it works, what it shows you, and why it's a game changer for ham radio operators. A modern pan adapter typically displays two things simultaneously on a screen, either a built-in radio display or a computer monitor. One, the spectrum scope, a real-time graph where the horizontal x-axis is the frequency and the vertical y-axis is the signal strength. Stronger signals appear as taller peaks. 2. The waterfall display, a scrolling visual history of signal activity over time. Signals move down the screen like a waterfall. Strong signals show up as bright colors, red or orange, while weak signals are cooler colors, blue or green. Before pan adapters became common, finding activity on a band required spinning the VFO, that is the tuning knob, up and down, listening for voices or Morse code. A pan adapter changes the entire workflow. Instant band activity assessment. You can look at the screen and instantly tell if a band is open or dead. If a contest is happening, you will see dozens of signal spikes. If it is quiet, the screen will be blank. Finding clear frequencies. If you want to call CQ, you don't have to ask, is this frequency in use on multiple channels? You can look at the waterfall, find an empty black space between signals, tune there and verify it is clear. Hunting DX, rare stations. When a rare station is operating split, listening on a different frequency than they are transmitting, a pan adapter lets you see exactly where the pileup is transmitting and where the DX station is listening. Identifying emission modes. With a little practice, you can identify the type of signal just by looking at its shape on the waterfall. CW looks like sharp repeating dots and dashes. SSP voice looks like irregular wider blocks, and digital modes like FT8 look like perfectly straight solid blocks. Historically, pan adapters were separate expensive hardware boxes connected to a transceiver's intermediate frequency output. Today, they are implemented in two main ways. One, built-in SDR transceivers. Most modern HF transceivers have software-defined radio architecture built right in. Radios feature large color screens that display the pan adapter natively without an extra hardware. 2. External SDR integration. If you have an older analog legacy radio, you can often tap into its IF output, sometimes using a small internal board like a PAT board, and send that signal to a cheap external SDR dongle connected to a PC. Software like OmniRig syncs your PC screen with your radio's hardware knob, giving an old radio a modern high-tech face. A PAT board, that is a panoramic adapter tap board, is a small specialized internal hardware modification circuit used to add pan adapter capabilities to older traditional analog transceivers. If you want to see a visual spectrum map on a computer screen, but your radio doesn't have a built-in digital display or an external IF, that is intermediate frequency output jack, a PAT board is exactly what you need to bridge the gap. Traditional legacy radios process signals internally through various intermediate frequencies before turning them into audio you hear. If you try to simply split the antenna line Before it enters the radio to feed an external software-defined radio dongle like RTL SDR, you run into major issues. Signal loss. Splitting the antenna degrades the signal going to your main receiver. Lack of sync. When you turn the radio's tuning knob, the external SDR doesn't follow along. Isolation risk. When you transmit, the raw power from your radio can easily blow out the sensitive front-end electronics of a cheap SDR dongle connected to the same antenna line. A pad board is installed inside your radio's chassis, acting as a safe, isolated buffer. Tapping the IF. It physically solders into a specific point on your radio circuit board, usually right after the first mixer stage but before the narrow crystal filters. This stage contains a wide chunk of radio spectrum, often 50 to 200 kHz or more, centered around your tune frequency. High isolation amplification. The board uses an amplifier circuit with very high reverse isolation. This allows it to sample the incoming radio signals without pulling down or degrading the performance of your main receiver. It also acts as a one-way street, protecting the external equipment. Impedance matching. It matches the high impedance of the radio's internal IF stage to the standard 50 ohms required by external SDR equipment. RF routing. The output of the PAT, that is Panoramic Adapter Tap board, is routed to a new connector, usually an SMA or BNC jack, that you install on the rear panel of your transceiver. Once the Panoramic Adapter Tap board is installed, your setup looks like this. Radio IF out via PAT board to external SDR dongle like RTL SDR RSP1A to PC software SDR Sharp or HDSDR. By using a software bridge like OmniRig, your computer coordinates the hardware tuning knob of your radio with a visual software display. When you spin your radio's VFO knob, the waterfall display on your computer clicks right along in perfect synchronization, giving a 20-year-old analog rig the visual powerhouse features of a modern SDR transceiver.